Okay, guys, welcome to the next topic in network layer protocols. In this section, we will actually discuss about Internet Control Message Protocol. Now, for those who have been following us from the IP protocol section of this chapter, we have already discussed what ICMP really does, but just to give you a quick review of why we need to study this and how IP addresses or basically IP protocols use this particular feature or this particular protocol in its activities is that IP protocol don't actually have any control message or any error reporting protocol within itself. If you remember, its entire datagram, which we have discussed in the past videos, it doesn't have anything for error situation, or if something happens to the packet, how do you go back and respond to the host? It doesn't have any of those. Okay. To come over that particular limitation, we have this particular Internet Control Message Protocol, or ICMP here onwards, as a feature which provide for this particular facility. Okay, so it provides us the facility of error reporting whenever something wrong happens with IP packet datagram. The ICMP message actually goes back to the host and tell whatever has happened, and not how to fix it, just that it informs the host that what has gone wrong. Okay, afterwards the host have to take care of. Okay, so even the ICMP doesn't solve the problem, it just identifies and tells the actual person who can solve the problem. Okay, other than that, there are a lot of management queries in the IP packet. We don't actually have facility for management queries, and management queries are those which help us understand the level of traffic or check the status of each of the routers. Okay, or to trace back a particular route to reach from point A to B, which is the best, or to calculate RTT or round trip time for each of the packets, and multiple things like these. So if you remember from the very first topic, we said that okay, internet is a graph, right? And in this particular graph, it should be weighted for us to understand which of the routes are actually more favorable compared to the other ones. How do you understand this particular weight? For those, you need to send demo packets, and they should come back based on the time that they have taken, based on how frequently they get damaged, or what amount of traffic they fail. Based on that, we can actually put some weight, right? So to send those sort of messages, we actually have ICMP protocol used for those activities as well. Okay. In this particular topic, we will actually discuss how the error handling happens, not the handling, error reporting happens, and the management query. What are some examples of management query? What is the structure of ICMP message protocol, which can handle all these things? So basically, ICMP is used for these two types of problem. Okay. Now, just as a reminder, since network layer is not the only layer here, network layer actually has multiple layers above it and below it. So whenever a packet, an IP packet actually goes, it doesn't just have to go through all these layers. For those who have actually studied, and this is something which I have seen most of the students actually remember, is that you must have studied that okay, application has sent a packet A. From that packet A, second layer has done some XYZ things, and it has added packet A and B called as encapsulated, and the next layer also do something like AB, and then it adds some part of it C, and so on. Okay, and when it goes to the other side from ABCDE, it goes to ABCD, and in the next one it goes ABC. Now most of us don't really understand how this thing works. It's not like we are adding some Lego parts into it, but this is what basically happens. Every layer takes the data from the above layer. It doesn't have to manipulate anything in that. It just adds some information which that particular layer has to provide in the entire let's say networking program, and it encapsulate that data with the data which it has added and pass that as another packet to the next layer. Okay, it can be called as datagram frame based on which layer we are dealing with, right? So what happens with the IP packet is that it doesn't actually go just like that. It has to be encapsulated by whatever has to be done by the layer below that, the data link layer, and that is something we need to remember because we will actually use that particular thing. On top of that, if you remember the particular protocol or the datagram structure, let me just clear it out. If you remember the datagram structure, if you don't, most of us don't, there is actually a column which has something called as payload. Sorry, not payload. Sorry, that was my mistake. Protocol. Yeah. So the protocol section, if you remember in the IP datagram, we discussed that this particular thing mention which protocol is actually using the IP address, right? So what we have here is that when we have to use ICMP, and given that error happen a lot frequently than being used by some other protocol, ICMP has been assigned the value 1. So if the protocol has a value of 1, you can understand that, okay, this particular IP packet holds the data for ICMP protocol. Okay. So that is enough about the introduction part of it. Let's get into a little more depth. There are mainly 4 types of ICMP datagrams, and they are classified into 2 major sections. Okay, based on the 2 problems that we are solving: error reporting and query messages. Okay, so whatever packet type we have, we classify it into 2 of these. Okay, the error messages are usually reported at the router because, or the final host or the destination, for example, where it has actually reached and something either has been corrupted, or problems like we discussed in the previous video, that no more fragmentation can be done, so I cannot handle this packet, or the checksum doesn't match, there has been some data, let's say the TTL is going to be over, some sort of data error has to happen. Okay, so those sort of error reporting messages are for type 1. Okay, for example, the problem which we have when we have the TTL going to let's say 1 in this particular protocol, and the next one, as soon as this particular hop happens, goes to 0. For that particular thing, we have another type in the section of the ICMP message. Okay, we have a column for the type. In that we have values from 0, 1, 2, 3, 4, and so on, and that basically identifies what type of error is this packet going to respond to. Okay, and to understand this a little better, we actually have to study the header portion of ICMP protocol as well. Now the ICMP protocol has 8 byte of header, and both of these error reporting and query messages have the first 4 as common. Okay, and in the next slide you will actually see what exactly those first 4 are. But the next 4 bytes is something that varies based on whether you have a error reporting or a query message. Okay, now discussing about the payload. Okay, because this is just the header, the payload has to be there as well. The payload, which we are not going to discuss in detail, basically handles 2 things. First, some sort of an identifier for not the problem that we had, because there is an identifier in the header as well. I'm talking about in the payload we have 2 sections. One is the identifier, which packet or device in the network we are dealing with. A packet when we have an error, a device when we are actually doing some sort of a management query, and the data that we actually need from it. Okay, so if a packet has actually gone wrong, we need let's say the first 8 or 10 bytes, or which particular sequence number it was holding, or something like what was the destination, something basically to understand that, okay, which particular part of the message has been lost. Okay, because we are reporting that something has gone wrong, what exactly has happened, that you have to put in the payload part of it. Okay, whereas if you do it for the device, you need to explain like, okay, I wanted to trace the route that a particular packet has actually captured. That is a management query or a message query protocol, message query of this particular protocol. And for that particular thing, we need to have the IP address of all the routers, right? So if I have sent a particular ICMP message and I need it to tell me about all the like routers that it has actually hopped on, I need to put that particular thing in the payload. Now the payload will actually change every single time based on what exactly has happened, or what exact management query which we have dealt with. And it is not actually something which we can study in a particular structure, because every network can actually set its own parameters. For example, let's say I'm actually handling a network which has let's say only a 15 or 25 key nodes and some 10 or 15 subsidiary nodes. Then I really want to know which of the nodes are making an error, because I can actually resolve them because they're just like 50 of them. Okay, but if they are taking way too much time, I don't really care, because I can't do anything, I already have way too less number of nodes. If I have a much bigger tech, then I need to focus on the time part of it. I don't need to focus on the routes, because I have way too many nodes to make a small diversion and change the entire route. Okay, so based on what exactly I can actually do, I can change the data that I want in my payload. Okay, based on what action I need to take, or what actually I can do, based on that I need the information. So the payload is something which is way too much of a variable, so we don't actually study that. But what exactly happens in the header is something that we can actually study, and we need to understand what exactly the information in the packet is going to be. Okay, so in the next video we'll actually discuss what exactly happens in the headers.